Hello guys, welcome once again. In this video, I'm going to teach you what is a virtual member function and what is a pure virtual member function. But before showing you how this virtual member function and how to declare this virtual member function, I must recommend you that you must know the basic concept of polymorphism in order to understand this virtual function because uh, this virtual member functions are generally used whenever you are using polymorphism. So I have shown you how to use polymorphism in the last video. If you don't know what is polymorphism, I have shown that in the last video, so please watch that. And I'm going to take the same example from the last video in order to demonstrate this virtual member function. So in the last video, I have defined a base class, which I call it as a shape class. And what my purpose was is I wanted to calculate the area of different shapes. So I have this base class called shape, and this was this shape class, which is my base class, have these member variable height and width, and have this member function called set values. And what this is doing, this is just doing this this is just setting the values of width and height here, right? And I've also defined a derived class, which I call rectangle, and which is inheriting from this shape class. And this has only one function called area. And this, what this was doing, this was just calculating the area of the rectangle by multiplication of height and width. And if you know, when you are inheriting from a class, its member functions are available in the derived class if they are private, or if they are public or protected members, right? In a similar way, I have defined this triangle class to calculate the area of triangle, and I was inheriting from my shape class. And this triangle class also had a member function called area, and I was calculating the area by multiplication of height and width divided by 2. And let's see how virtual function work. So first of all, what is a virtual member function? A virtual member function is a member function that can be redefined in the derived class. Okay, so let's see how we can define a virtual member function. Uh, One more important thing is you can define a virtual function or virtual member in your base class only. Okay, so my shape class is the base class, so I can define the virtual member function here. So how you can define, you just need to use the keyword virtual and then the normal definition of a member function. So for example, I want to call my function as area, so I will just define the function called area, which takes no argument, and it returns 0, for example. Okay, so this is how you can declare a virtual function. And what is the use of defining this virtual function? So if you define your member function as a virtual function in your base class, you can provide the redefinition of this function in your derived classes. So I have this virtual function called area. I can provide the redefinition of this virtual function in my rectangle class by the same name area, like this. And I can even define the same or redefinition of this function in my triangle class. By redefinition, I mean the name of the function is same, or the prototype of the function is same, but the implementation is different for different classes, or the implementation is depending upon the class in which it's defined. Okay, so the prototype is same, which is int area, and the definition is different. In the case of rectangle, I was calculating just height into width, and in the case of triangle I'm calculating the triangle area by height into width divided by 2. So the basic use of virtual function in the base class is just to tell C++ that we have defined this function as a virtual function because we want to redefine this function in my derived class, and I want to redefine the definition of this virtual function in my derived class according to the requirement of the derived classes. And this virtual member function you can use as a normal virtual function whenever you want to use it in the main class. So for example, I declare a instance of this poly. uh, by the way, this code I have written in the last video, right, if you remember. And I have defined the instances of my derived classes rectangle and triangle like this, rec and try. And this I have also defined the uh, instance of my base class, which I call it poly, right? And according to the polymorphism concept, I can point to this derived class using my base class like this. So I can define a pointer which has the reference of my derived class object. Okay. In a similar way, I have done the definition of this triangle derived class also. And in a similar way, I can point to my base class also. So this is the instance of my base class which is pointing to the base class itself. And I can set these values, set values which I have defined in my base class, you can see, which set the value of width and height here. And then I can calculate the area of the specific member or specific class for the specific class. So rectangle gives the area of rectangle, triangle gives the area of triangle, and poly gives the area of polygon which I have defined. And I can compile it and I can run it, and it gives the area like this. So the area of rectangle is 200, which is 10 into 20. Rectangle area of triangle is 100, which is 10 into 20 divided by 2. And area of poly is 0 because we have defined a virtual member function which was returning 0 here, right? Now this is about virtual member function. Now what is a pure virtual member? So a pure virtual member is a member which have no definition. So right now I have defined a virtual member function like this, and this is returning 0 here. That means I have provided some definition to my function. But if you want to tell that this is a pure virtual function, you don't even provide any definition here. And how you can say that this is a pure virtual function? You just need to assign 0 to this function, and then tells this type of declaration tells C++ that this is a pure virtual member function. And what is the speciality of this pure virtual member function? The speciality is you don't even have to give the definition to this pure virtual member function in your base class. You can redefine this virtual member function in your derived classes like this. Okay. So this is a short way of telling C++ that you have this function in the base class which you want to redefine in your derived classes according to the requirement of the derived classes. So you can do it like this. This is how you can define a pure virtual member functions. Okay. Now suppose, for example, I don't give the definition here uh, of this pure virtual member function. Okay. And I don't calculate the area of this rectangle also, for example. And what I'm going to do is I'm going to compile my program. So I compile it and it gives me the error. Okay, and why it's giving me the error? Because it says cannot declare variable poly to be the abstract type shape. So this error is coming because I haven't defined, or I haven't given the definition of member function or pure virtual function area in my rectangle class. So this is the restriction of pure virtual function. If you define a pure virtual function in your base class, you need to redefine the definition of this member function in your derived class, otherwise it will give the error. Okay, so I haven't redefined this area member function in my rectangle class, which is deriving from the my shape class. So this is throwing an error, or this will give the compilation error, right? So I have to give the definition of this member function, virtual member function area in my derived class, otherwise it will throw an error. So once again I will define the definition here, and once again I compile it, and it will run fine, I think. Let me see. And once again, it cannot declare variable poly because it's abstract type. Let's see. Yeah, so once you have this, you know, once you define your function as a pure virtual member function, it makes your class as an abstract class. And what is the abstract class? Abstract class is a normal class, but the speciality of the abstract class is it's just the definition of the class. So abstract class are something very similar to our shape class, and abstract classes are just the definition of the member function, and no implementation is given here. Okay, so we haven't given any implementation of the area function, so we cannot define this object here. This is true. And once again compile it. Yeah, I need to remove this also, and this will not give me an error. Okay, so always remember that if you define your member function as a pure virtual function, this makes your base class as an abstract class, and abstract class is a class which have only the definition. Okay, so not the definition but the prototyping definition you provide in the derived classes. Okay, so notice that our area here has no definition. Okay, so I hope you have understood the concept of pure virtual function and virtual member function, and I hope you have enjoyed this video. Please rate, comment and subscribe, and bye for now.